All right, so here's some problems that are going to help you get through some of your homework tonight. So I started reviewing this one in class. The reason that we're able to split up these roots into smaller pieces is because think about what we do when we are simplifying radicals. So for example, if I gave you the square root of 125 and I asked you to put that in simplest radical form, we have a property that tells us that we are able to separate this into something that would look like the square root of 5 times the square root of 25, which we're able to do as long as the index is the same. Well, here, all of these terms are all underneath the square root. So what I'm able to do, and what I suggested that you do, might be to separate out whatever the numerical value is underneath your root and separate them from the variables. The reason that this is helpful is because I think that it's a lot less daunting to have the constant or the number just kind of be on its own and be able to simplify this as it is. So square root of 49, obviously that one's pretty easy. So it's a 7. And then we're able to deal with the variable separately. So what I would probably suggest doing in this case is I would probably rewrite this root as the quantity of x to the 8th, y to the 4th, all raised to the 1/2 power. And the reason that I would suggest rewriting in terms of a fractional exponent for these variables is because now we can use the power to a power rule, which says that basically this 1/2 power is going to be multiplied by each one of the exponents on the inside of the parentheses. So I'm going to bring down the 7, and then this is really multiplied by x to the 8th to the 1/2. So that's going to mean that we want to multiply the 8 and the 1/2. So that's going to give us an x to the 4th. And then y to the 4th raised to the 1/2. We're going to go ahead and multiply that. So it's going to give us a y squared. So in simplest form, the square root of 49x to the 8th y to the 4th is 7x to the 4th y squared. And then what we can do is we can actually kind of do something a little bit similar with this example, which was example 4 in the notes from Monday. We can use the power to a power rule that says basically, okay, now that we've got a power on the outside, we need to make sure that both terms on the inside get that power. So I can rewrite this as 27 to the 2/3 power times x. And then again, power to a power means that we want to multiply these. So 9 times 2/3 is going to give me 18/3. And then what I'm able to do again is just work with the constant value separate from my variables. And probably what I would suggest doing here is I would probably rewrite this in radical form. And this is kind of what we were practicing on Monday, because if I rewrite this as a radical, here my radicand is 27. My root or my index is 3. So that means I have the cubed root of 27. And my exponent is 2. And then I can go ahead and pull this term down. So 18 divided by 3 is going to simplify to 6. And then this makes it a lot easier to simplify this number, because what we want to do is follow our order of operations. We want to do the inside, take the cubed root of 27, which is going to be 3, and then raise that to the exponent of 2, and then whatever that result is gets multiplied by the x to the 6. So in simplest form, 27x to the 9th all raised to the 2/3 power is actually 9x to the 6. Okay, so we'll just do a couple of more examples. These are extra, these weren't from the notes, but kind of the same idea as number 3, except for this one, I didn't write that very well, but this should be a cubed root of 125x to the 21 y to the 18th. So the same rule still applies as up here. We are still able to kind of pull these roots apart if we need to. And again, I'm going to separate out the numerical part from the variable part. So I'm going to rewrite this as the cubed root of 125 times the cubed root of x to the 21 y to the 18th. And the reason that it's helpful to do this is because now I can easily take the cubed root of 125, which should be 5. And then I'm going to kind of do the same thing that I did in the example number 3. I'm going to rewrite this quantity as a fractional exponent. So I'm going to take x to the 21, y to the 18th, and I'm going to raise this to the 1/3 power. because it's all underneath a cubed root, so that's equivalent to 1/3. And then I can go ahead and use my power to power property. So bring down the 5. X to the 21 times 1/3 would be x to the 21/3. Y to the 18 times 1/3 would be y to the 18/3. And then these are both evenly divisible. So we can go ahead and divide those to get 5, x to the 7th, y to the 6th. Okay, so what happens if like maybe the number on the inside like isn't a perfect square? So what happens if it's something like this when I have a 56 x squared y to the 4th underneath the square root? Well, I'm still going to start off the same way, and I'm still going to say, okay, well, what if I write this as a square root of 56 times the square root of x squared y to the 4th? I'm going to work with my number separate from my variables. Well, I know that I can get the square root of 56 into simpler radical form. I think that is evenly divisible by 4. So I'm just going to separate that out and say that's equivalent to the square root of 4 times the square root of 14. And then I'm going to go ahead and rewrite this quantity with a fractional exponent to the 1/2, because again, 1/2 is equivalent to our square root. And then I'm just going to simplify. So this is going to end up being 2 root 14 for my simplest radical form of the square root of 56. And then I'm going to go ahead and use my power to a power property. So that's going to give me x squared times 1/2. So x to the 2/2. Y to the 4th to the 1/2 is going to be y to the 4/2. So if we kind of clean this up a little bit, that's going to give us 2 root 14 times x y squared. Seems a little weird the order that this is written in. So usually we would write whatever the values are that are not underneath the root first, and then whatever's underneath the root gets written last. So I'm going to write this as 2x y squared times the square root of 14. And that would be our simpler or simplest form of the square root of 56 x squared y to the 4th. So hopefully this helps for your homework. Let me know if you do have any questions.